Okay, so word problems. And it's interesting, in my notes, right about now is where we had the shutdown last March. So interesting. Okay. Draw 4 word problems. Okay. What you want to do is you want to interpret it. What does interpreting mean? You want to read and kind of have a mental picture as to what's going on. Okay. Use common sense, right? A lot of times we're not using common sense, right? What would make more sense based on what I'm reading here? Give it another read, highlight, underline things that are sticking out, right? And then you want to draw a labeled diagram. Okay, that's very important because especially if you misinterpret and your diagram is drawn differently, yes, you will lose marks, but you will still earn marks if you base your work uh, base it on your diagram. Okay, so and you will show work. This means like all steps, proper notation, and units. Round final answers to 2 decimals. This is sides and angles, the same thing. Okay, even angles you want 2 decimals there. Some definitions. We will deal with angle of elevation. And the angle of elevation is the angle between the horizontal and the line of sight looking up. Okay, and I'll have a diagram after this for both angle of elevation and depression. Okay. Angle of depression, angle between the horizontal and line of sight looking down. So angle of elevation, angle of depression, there it is. So just to give you an idea, right? So there's this individual, right, looking out, and so the horizontal would be going like that, horizontal line. And then there's a line of sight going up and one down. Okay. So between the horizontal and the line of sight going up, let's say that'll probably be a bird or a tree or an airplane, right? Let's say it's a bird, right? Flying up there. That'd be the angle of elevation. This angle right here is the angle of elevation. And then there's the line of sight looking down. Okay, so let's say you see, a bug crawling around, right, on the ground. That would be your angle of depression. So it's measured always between the horizontal and the line of sight looking down. So you have your angle of elevation, angle of depression there. Okay. So when there's an angle of elevation mentioned, yeah, it's not, definitely not. Okay, right? Angle of elevation, the triangle will look like this and like this. Okay, so you have this is the angle of elevation. The triangle will most likely look like that, okay? The triangle that results from it. And oftentimes, quite often, it results in a right triangle when it deals with that. But sine law can take care of that, okay? It can work with right or obliques, right? If it's a depression kind of question, the triangle will look like this, and there's your angle there, or it might be, right? So a classic example is a ship scanning the bottom of the ocean with radar, and all of a sudden it notices an object at a certain angle of depression, and so that angle you should know, okay, my triangle will most likely look like this or like this, depending on which way it's coming from. And angle of elevation, obviously there's like a tree a person's looking at a tree or at a plane or something flying up there, a kite, doesn't matter, a blimp, right? You name it, angle of elevation, okay? So there it is. You also need to remember your supplementary angles. When the sum of two or more, we always think it's always two, right? They're supplementary because, if one is 120, the other one is 60, yes, but it could be more angles involved, right? Two or more angles is 180 degrees. So I give you an example here, right? If this is the straight line, right? You could have a small one like this, right? So this could be angle X, Y, and Z, right? Around that point, they add up to 180. So that'll be helpful if you know two of them, right? You can find the third, and that's basically very much related to the unit we just did, okay? And now I'm going to give you a shortcut as well to find the height of the triangle. This one I call this would be under the items of interest, right? Height of triangle. This is the quickest way of doing that, and it works every time. You can do it the way I just showed you, but this is a shortcut. So let's say you have a triangle like this, and you know that, let's say we call this angle here A, and we call this side S here. That's the measure of this side that's touching the angle. in general, the height of this triangle, which is coming down here, will be S, side S, so this side right here, whatever that measures, times sine of angle A. Okay, that's a guarantee. It also works with an obtuse. So this would be an acute angle. Same thing for an obtuse. So if you have an obtuse triangle like this, okay, if this is A, then in this case, I shouldn't have called it S, right? Because some of you think it's a 5. It's not 5 times sine of A, okay? It's whatever this measures. I should have called it X. Maybe, you know what? Let's do that. I know some of you are going to be upset because you're using a pen, and I use pen too. I'm just going to white it out. I don't want that to happen, okay? So we're going to call this X, X, okay? So this here will turn into X as well. There it is. So this is X times sine of A. So for this particular triangle here, the height, which will be a little messy, the height would be measured here, right? It makes a 90 with the ground, right? So the height is here, but it works for both of them. If you know this angle and the side that's touching it, it's not the base. It can never be the base. It has to be the side that's going upward, right? You multiply that side length by sine of this angle. And it works in real life. It works for any application. If you ever want to quickly find the height of something, measure that angle. And if you know the side, you go side length times sine of A, whatever this measures, and you find it, right? So keep that in mind. It's going to be very handy down the road, okay? So I think I would just like you to see that. We found the height earlier, right? Here. I'm just going to show you. You don't have to copy this, but we found the height to be 2.34 inches, right? We had to do all of this here. But really, once we found the 3.25, this here, that is this side here, right here. So technically, by that reasoning, we could have said, hey, I know the height is 3.25 times sine of 46. So let's go ahead and do that, right? 3.25 times, I'm going to clear my screen here. 3.25 times sine of 46 gives me 2.34 rounded, which is exactly what we found, okay? So it saves you having to do all of this. And there it is. Now you know why the shortcut is important. All right. Okay, keep going. I'll at the very least, I'll get you to copy down the word problem so that tomorrow we can just solve it, okay? And I introduced some weird wording on purpose so that you get used to it. So the Tower of Pisa has a 10-degree slant from the vertical. An observer is standing 325 feet away, and I'll be very specific here, towards west. So you're not confused, right? And is looking to the top of the tower at an angle of elevation of 27 degrees. Okay, so that's the word problem. A, determine the length of the tower. B, calculate the direct distance between the observer and the top of the tower. Let's write that down and we'll try to get at least the interpretation as well as we'll interpret it, sketch it, right? And then try to solve at least for the A part. And I have no way to gauge if you're done or not, but that's why I write it out. I have it all written down already, but if I write it out, I feel like I'm kind of close to your speed, right? Okay, so this question is still not 100%. It's not as specific as I would like it to be. And when it's quite vague, I would probably start you off with a diagram and then you have to fill in information. Okay. So for A, we will interpret this thing. So the tower has a 10-degree slant from the vertical, it's saying. What does that mean? Well, imagine for a second here that this is the ground, right? This is the ground here. And the tower is standing because the observer is to the west of the tower, right? If you read it. So if this is the tower is standing here, there's a vertical here, right, which makes a 90 with the ground, but the tower is leaning, right, 10 degrees off of it. So if the built originally built, it was perfectly 90-degree with the ground. Now it's slanted 10 degrees from the vertical. Okay, so this is the vertical here. So 10 degrees off, so we're gonna exaggerate a little bit, right? And so this is our 10-degree shift from the vertical. And so our tower, right, is standing like that. And now we need to figure out other information. We know that our bystander is standing right here. This is the observer. And I know that the distance between the tower and the observer is 325 feet, right, towards the west. That's where the observer is standing, right? And so you have to recognize that there is a triangle emerging, right? So you've got this side of the triangle. The tower itself will be 1. So I'm gonna make that line of the tower, right, along the center, or as much as possible. And then there's one which is the line of sight to the top of the building, right? So here you have your triangle that came out of this question, right? And see if we can fill this in, right, with more info. It's saying that the angle of elevation is 27 degrees. And we know that the angle of elevation is between the horizontal and the line of sight looking up. So this right here is 27 degrees. Okay. What else do we know? I think that's all we know at this point. So do we have a pair at all? 27 doesn't have this side across from it. 325, it would technically be this angle up here that would be across from it, right? So we don't have anything going here. We need a bit more. And it's hidden here. If this is 90 and you add another 10 to it, we know that this whole thing here is 100 degrees, right? The 90 and the 10 makes it 100. So there you have a lot. Now you have angle, side, angle, right? This is an ASA scenario. And that's the hidden pair scenario, right? So let's call this something here. Let's call this angle A. And let's call this B. And let's call this point right here C. I know it's a little busy here at this intersection, but just know that there's a triangle there, right? And sorry, and so this angle, the whole thing is 100 here as well to this line, right? It's the same 10-degree slant, so we're gonna just go to the center, so it's 100 there. So angle A is going to be 180 minus the 100 minus the 27. Angle A turns out to be 53 degrees. Very important to us. Now we have a pair. We have a pair now, right? Sine law. So now we're going to attempt to solve for A, or for the length of the tower. This is what we're after, okay? So we're going to go sine of 53 over 325 is equal to sine of what? We have to be careful. We want the length of the tower, so we have to take the angle that's across that side. So this is sine of 27 over, what are we going to call this? Lowercase b? We're going to call this lowercase b. So b is going to be 325 times sine of 27 divided by sine of 53. Oh, there, my bad. And right, once it gets to here, once it gets to solving, you should have a pretty good idea of what to do. It's the whole interpreting, but don't overthink it. Like sometimes students overthink it and then they freeze, right? Like where do I draw this line of the tower, right? Like for all means and purposes, you don't even need to draw the tower. You just have a line going from C to A and just call that your tower, right? And so this gives you 184.75. Use common sense. That's what I tell students. Okay, use common sense. So we're gonna stop there because I don't want it to again go over time here. We're gonna continue with the other part. I am quite certain that at this point you could figure out what B is. Okay. So we're going to continue with that tomorrow. I'll do another word problem and then I can assign some questions to you that will challenge you. Okay. Tomorrow I will also do an AC on just basic sine law. I don't think there'll be a word problem on there, but just sine law and how to use it, finding the height perhaps, finding the side length and angles. You got to be familiar with all of that. Maybe even solving a triangle. So review that and make sure you know how to do that, okay? All right, at this point you can log off. Have a good day and see some of you tomorrow.